So here is our second set of data, which, looking at the title, was measured on November 3rd, the day after, and also GNSS and total station observations. So now we follow the same process, and you'll do the same process in the monitoring module for each epoch of data, starting with the assign monitoring project command. Now in this case, we've already created the monitoring project, so we don't need to create it again. We just select that existing project, and we call this building monitoring example. And then we select the appropriate timestamp for this set of data, which was November 3rd, and press save. And of course, we'll go through creating the monitoring points again. Now in this time, you'll see that the points have been automatically selected. And what this has done is selected any point IDs in the TBC project that match any existing point IDs in the monitoring cloud project. Now create those points, and once again, they'll be shown in red, meaning we'll need to synchronize the monitoring project to get our displacement data. Now, once that's synchronized, you'll see that now we have 3D displacement vectors that are shown from the first to the second set of data, so the displacement of that point over time. For example, if I zoom in, these vectors scale automatically. If I want to look at WCO1, TSO5, I can select that arrow, right-click, and view the properties. In the properties, I can see that the displacements are far out of the tolerance. Now, if I decide that these thresholds are too small and I want to change them, I can do so. For example, if I change these to 3 centimeters and the 3D alarm to 5 centimeters and the elevation alarm to 5 centimeters. I'll need to sync the project again, of course. Now you notice in the plan view, the displacement vector is now yellow, which means it's out of the warning threshold, but it is not out of the alarm threshold. So anything in red is out of the alarm, and anything in yellow is out of the warning. Anything in green, which it currently looks like we do not have, is within both thresholds. Now that we have two sets of data, we can view the monitoring point spreadsheet. This shows us all of our current monitoring points, whether they have tripped either the alarm or warning thresholds. And we see we have some points that have and some that haven't. And then the displacements in 2D, 3D, easting, elevation, and northing components, and the associated alarm levels that we have set. If you'd like to take this data, you can simply select it, right-click, and copy, and paste it into an Excel or text document if you'd like. You can also use the columns to sort and filter data as necessary. For example, if I only want to see points that are out of an alarm tolerance, I can select that. Next, we have a monitoring point chart. Before running this command, you'll need to select a monitoring point. For example, we'll select WCO2_06, and then open the monitoring point chart. Here we see an interactive chart for that point's displacements. At the top we see the title as well as the date range for that point from November 2nd to November 3rd. On the left-hand side of the chart we see the displacement, in this case displayed in meters. On the bottom we see the date range. And you'll notice if I select the chart that it gives me a prompt of what the displacements were at that date. Of course, the date that was the earliest in the monitoring project is the reference date, in this case November 2nd. And because we only have two sets of data, we only have a second point here on the right-hand side which is our November 3rd date, showing the displacements in 2D, delta 2D, delta elevation. Now, if I want to view multiple components of displacement, I can click on these values to show all values of displacement. And now I'm seeing both not only the 2D and elevation, but also 3D easting and northing components. If I'd like to view a single component, such as 2D, I can see relative to the thresholds where my measurements fall. For instance, anything above this red line is out of the alarm threshold, and anything above the orange line or yellow line is above the warning threshold. I can also scale this time series. In this case, I only have 2 sets of data, so it's already scaled as far as can be. And I can print this time series out as well to a chart or to a PNG JPEG. The last deliverable in the TBC monitoring module is the comprehensive monitoring points report. The next thing we'll show is the TBC monitoring displacement report. So in this case, this report can be found here on the TBC monitoring ribbon. Now, once the report is generated, we can see at the top we have some statistics about the project, such as the time and date range and coordinate system information. Now, if we scroll to the first section, we have our scatter plot of displacements. The points are colored based on when that measurement was taken. So in this case, the pink is more on our November 3rd, November 4th time range, and orange, which you would not be able to see because it's placed at 00, is our November 3rd data set, or our November 2nd data set. This is a useful chart for picking out outliers in the data set. For instance, we can see there is a measurement out here that is far from the norm. On the axes, we see the displacements in easting and northing components, as well as delta height, delta northing, and so on. The next section of the report is a time series displacement chart showing an easting, northing, and elevation components of all points. So in this case, we see all of our monitoring points. As well, the blue line depicts a rolling average of the displacement across all points. Continuing on, we next have the same type of displacement charts, but for each individual point and their corresponding components of displacement. Now, any points outside of the alarm threshold will be shown as red stars, shown here, and any points outside of the warning threshold will be yellow triangles. And we can see an example of a yellow triangle here. And these point charts are created for each monitoring point. Now, the last section of the report is a tabular view, starting by showing the component thresholds that are set for each of those points, as well as a table for each epoch of data. So in this case, November 2nd was our baseline, so there's no displacements. But if we move to November 3rd, we can see the deltas to the previous epoch, as well as the deltas to the reference flagged according to the threshold. Now, if we want to print this report, we can download as a PDF or else run to a printer option. The real power of the TBC monitoring module is being able to visualize and report on this displacement data using the data integration capabilities and 3D viewing power in TBC. For example, in this project, we have GNSS and total station observations with a combined network adjustment showing displacements, as well as a 3D model showing the position of those points, giving us context where this movement is occurring. For example, if I rotate, I can see in 3D that this displacement is trending almost in an upward and southerly direction. The comprehensive reporting also brings an additional aspect of confidence in the monitoring data and provides a streamlined way for generating useful deliverables to meet client requirements. This concludes a demonstration on the TBC monitoring module.